Okay, so yesterday we learned to solve systems of equations by substitution, and today we're going to learn to solve systems of equations by elimination. And it's really easy. All that means is we're just going to eliminate one of the variables. I'll show you how to do it. It's simple. So there are steps to solving systems of linear equations by elimination. If you are a note taker, now would be the time to pause the video, copy down these notes so that you can have them, so that you can refer back to them. They'll be your little cheat sheet for tomorrow's classwork. All right, so pause if you need to. All right, here's the first example. The first example gives us the two lines, 3x minus 4y equals 10, and x plus 4y equals negative 2. Now we're going to solve by elimination. The first thing that I notice when I look up here is that I have a negative 4y and a positive 4y. So in my head I'm saying, well, negative 4y plus positive 4y is 0. So essentially we just eliminated those. So I'm going to take these two equations and I'm going to rewrite them, and I'm going to solve for x. So I'm going to rewrite my equations. I'm going to start there, lining up all of my variables. So my x's come first, so I'm going to add this second equation to the first. I've lined up all my variables. So step one, done. Now I'm going to start eliminating. Well, 3x plus x is 4x. Negative 4y plus 4y is 0. And then 10 minus 2 is 8. So this is 4x equals 8. Divide both sides by 4. X equals 2. So now I can go back and plug in this x equals 2 for either one of these two equations that were my originals. I choose to plug in for the second one. Now, if you like the first equation and you want to plug in for it, you're more than welcome to. So I'm going to plug in this x right here for 2. So 2 plus 4y equals negative 2. So yesterday, just like we and the day before, when we solved for systems and we found a solution was an ordered pair, I already have the x for my ordered pair. I plug it in so that I can get the y for my ordered pair. So I'm going to subtract 2 from each side. 4y is equal to negative 4. Divide both sides by 4. Y is equal to negative 1. And since it's the first example that I'm doing, I'm going to go ahead and double check my answer by plugging in my x equals 2 in my first example, just because it's the first one I'm doing today and I want to make sure that I did it right and that I'm teaching you guys how to do it correctly. So 3x, I can replace that x with 2. So 3 times 2 minus 4y equals 10. 6 minus 4y equals 10. Subtract 6 from each side. Negative 4y is equal to 4. Divide both sides by negative 4. Y equals negative 1. I was correct. So my solution to this system is 2, negative 1. And that's the answer.
Or what we could do is plug in the ordered pair 2, negative 1 into the top equation and the bottom equation and make sure we get two true statements. That's what we did back in section 6.1 when we were testing to see if an ordered pair is a solution. So
Absolutely.
Great ways to check your answers.
All right, so the second one that it gives me here, step 1 is not already done for me. I can clearly see by looking up here that my variables are not lined up. So what I'm going to do is I'm going to rewrite this second equation and line it up with my variables in the first equation. So I know that I need my x's to be first, my y's, I need my x's to be first, I want my y's to come next, and then I want my constants to be on the other side of the equal signs. So the first thing I see is that my constants, negative 13 minus 5y equals negative 2x. I can move my constants to the other side by adding 13. So if I add 13 to each side, that gives me negative 5y is equal to negative 2x plus 13. Now I want my x's to be at the beginning, so I'm going to add 2x to both sides, giving me 2x minus 5y equals 13.
Why did we not write the negative 5y first? Why did you write 2x first?
I wrote 2x first because in my original equation, the one on top of here, I want to line up with it, and since all of its x's are at the beginning, I wanted my x's down here to be at the beginning.
Okay.
All right, so now I'm going to solve by elimination. 2x plus y is equal to negative 5. 2x minus 5y equals 13. All right, now I want you to look at this and ask yourself, can I go ahead and start eliminating?
Yeah, 2x and 2x.
Yeah, but 2x and 2x are not going to eliminate. What's 2x plus 2x, Ms. Sokolowski?
Oh, 4x.
That's 4x. So I know that I need to make one of those 2x's negative. Well, that's easy. How do I make a positive into a negative?
Just write a negative sign in front of it.
I can't just write a negative sign in front of it because I'm talking about everything inside of this equation right now. If I multiply by a negative, I have to multiply everything inside my equation by a negative. So I'm going to change this equation again by multiplying everything inside by negative 1. Just like you use the distributive property. So now I have negative 1 times 2x, that's negative 2x, negative 1 times negative 5, that's 5y, negative 1 times 13 is negative 13. So now I can take this equation and I can begin eliminating. So, going back, I'm going to take my top equation, 2x plus y equals negative 5, and my new equation with my negative 2x, negative 2x plus 5y equals negative 13. And now I can eliminate because I have a positive 2x and a negative 2x. So we know that that's going to be 0. Y plus 5y is positive 6y, and negative 13 plus negative 5 is negative 18, which leaves me with the equation 6y equals negative 18. Divide both sides by 6. Y is equal to negative 3. So now I know what my y value is as far as my solution goes. I know that my solution is an ordered pair. If I know the y value is negative 3, I'm just looking for my x value, and I can get that by doing what step, Ms. Sokolowski?
Plug it back into one of the equations that we were given, either the top one or the bottom. But it looks like to me it'd probably be easier to plug it in the top one since the y is all by itself.
That is an excellent thing to notice. So I'm going to say that 2x plus, well, my y here is negative 3 is equal to negative 5. So I'm going to, that negative makes it a minus. I'm going to add 3 to each side. So this is 2x is equal to negative 5 plus 2, negative 2. Divide both sides by 2, x equals negative 1. So the solution for this system of equation is the point negative 1, negative 3. You're more than welcome to give me a check on that by plugging in this ordered pair. By plugging in this ordered pair for this and making sure that you get a statement that negative 5 is equal to negative 5.
Now I have a question. Going back to this, we tried to cancel out this 2x right here with this 2x by multiplying both sides by negative, but I already see this says positive y and this says negative 5y. Well, I know a negative 5y and a positive 5y cancel, so could I just have gotten this to be a positive 5y instead? Just multiply everything by a 5? Could I have done that?
Yeah, absolutely. That would just been another way to do it when you'd ended up with 10x plus 5y is equal to negative 25.
Okay, just wanted to make sure I could do either one.
You're so smart.
All right. Next example.
Okay, so some cases you'll first need to multiply by one or both. We've kind of already dabbled into this, but this is just a bigger example. So when it gives you a system of equations that looks like this, where we don't have anything that is equal to one another, so now we need to start deciding, well, what do I want to get rid of? Well, here's what I notice when I look at this. I notice that this is a positive x. This is a positive x, and that's a negative 3x. So I could make that a positive 3x, and I could do that by multiplying everything in this equation by 3. And that's going to help me eliminate this negative 3x down here on the bottom. So I'm going to make this top equation 3x plus 6y is equal to 33. Now if I rewrite my equations and stack them, I've got 3x plus 6y equals 33. If I add that to negative 3x plus y equals negative 5, then I can eliminate this 3x. So positive 3x minus 3x is, well, that's 0. 6y plus y, well, that's positive 7y. 33 plus negative 5, or 33 minus 5, is 28. Divide both sides by 7. Y is equal to 4.
I have an idea. Why don't we stop here and let's see if they can get the x.
Okay, so let's stop here. I'm going to go ahead and pause the video. I'm going to solve for x. So you go ahead at home and you pause the video and you solve for x, and we'll check our answers. Okay, so I've gone ahead and I solved for x. I got that x equals 3. So the ordered pair 3, 4 is a solution to this system.
Be careful you guys write that in the right order. Even if you solve for y first, don't be tempted to put your y first in the ordered pair. Y always goes second, guys. Be careful for that. All right, let's look at one more example
This
here.
is the last example, and now I'm looking at this, Ms. Sokolowski, and I'm like, oh my gosh, this is crazy. I can't multiply just one of them. I'm going to have to multiply both of them. So I have to start asking myself, okay, what do I know about greatest common factor, least common denominator, all of that stuff that you learned in 6th grade? This is the application. So we're going to take this, and I'm going to make this 6x. I want both of these. I want this one to say positive 6x. I want this one to say negative 6x. So how can I get 2x to 6x? I know that 2 times 3 is 6, so I'm going to multiply everything in this equation times 3. So I have 3 times 2x plus 5y equals 26. And now I'm thinking, well, what can I do to this bottom equation to make this negative 3x negative 6x? Well, if I multiply everything in this equation by positive 2 times negative 3 is going to give me that desired negative 6. So I'm going to multiply everything in this equation by positive 2. All right, so I'm going to work these guys out. This is 6x plus 15y is equal to
78.
78, thank you. And then this is negative 6x minus 8y is equal to
Good afternoon, North.
negative
Just a reminder,
50.
if you have not
So I'm going to
completed
set these two guys
make sure you go
on top of one another. Their variables are already aligned, so I'm just going to eliminate, just like we've been doing. So 6x plus 15y equals 78, and negative 6x minus 8y equals negative 50. So 6x minus 6x is 0. 15y minus 8y is positive 7y. 78 minus 50 is 28. Divide both sides by 7. Y equals 4. So go ahead and I'm going to pause it. You solve for x. Let's see if we get the same thing. Okay, I solved mine. I plugged this 4 right here. Oops, sorry. I plugged this 4 right here in for the y, that was at 5y in this top equation, and I got that x equals 3. Now for tomorrow, you guys need to solve these three systems of equations using what you know and learned today. Do the best you can. If you screw it up, you screw it up. Who cares? This is just your practice.